Number 11, perform the following operations. Express each answer in scientific notation. So here we go. Now the first type of problem I run into here is an addition problem. That means before I can continue, I have to make sure that these numbers are both to the same power of 10. Here I have a minus 2, here I have a minus 1. They either both need to be minus 2s or both need to be minus 1s before I can continue. It doesn't matter which one you change as long as they're both the same power of 10. So for this example, I'll just try changing this negative 1 to a negative 2. And so this will become, again, I'm changing this to a negative 2. The notation is getting smaller, but this value is staying the same. So this number is going to appear to get larger. So I'm going to have a messed that up already. 28.6 times 10 to the minus 2 grams. This is staying the same because it's already times 10 to the second. And I'm going to add, excuse me, I'm going to add these bad boys together. Now I could change both of these to minus 1. That would be perfectly acceptable, in which case I would keep this value the exact same, and I would make this a larger notation, but to still keep the value of this the same, I would have to move that decimal over 1. So this would be 0.154 times 10 to the negative 1 gram, and I would simply add those together. So either of those will get you the same number. Now, it might not be in the same notation. Okay, it might not be in proper scientific notation because the number you get might not be between 1 and 10. For example, the 28.6 right here, you can tell that adding 1.54, it's not going to be between 1 and 10. You're going to have to move that decimal. This, on the other hand, let's get my calculator back over here. This 0.154 plus 2.86, that ends up being 3.014 times 10 to the first grams. Okay, move that calculator out of there. This is already in scientific notation, so the only thing I need to make sure of here is that I'm reporting the correct number of significant figures. 2 past the decimal, 2 past the decimal. So 2 past the decimal here. This 4 tells me to keep that 1 the same. So my final answer will be 3.01 times 10 to the negative 1 grams. Now here's the thing. If you punch this into your calculator, you will get 30.14 times 10 to the negative second. That's simply not in scientific notation. So you're going to have to move the decimal over 1, okay, one place to the left. That will change your exponent back to negative 1, and so you'll still come to this final answer. Let's try it with B. We have a times 10 to the 9th, and we have a times 10 to the 7th. Okay, so I can either move the 7 to a 9, or I can move the 9 to a 7. I'll try to move the 7 to a 9. So I'm going to move this decimal 2 places to the left, so that will be 0.0662 times 10 to the 9 grams. This value stays the same. Bring the calculator back in. Now that they're the same power of 10, I can simply add them. So calculator tells me 7.0892 times 10 to the 9 grams. But again, is this the correct number of significant figures? 2 past the decimal, 3 past the decimal. This is a smaller number, so this needs to be 2 past the decimal. This is 2 past the decimal, but this 9 tells me to round that up. So the answer that I will report is a 7.09 times 10 to the 9th. Oh, did I add that? Goodness gracious. Mistake time. Let me go back. Who here saw that I pressed a plus instead of a minus? Who let me do that? You guys are in trouble. It's 7.023 minus 0.0662. Haha. Oh, erase all that. That was just a waste of time. That was a waste of time. I hope you guys noticed that I made that mistake and pressed plus instead of minus. So it's actually 6.96 times 10 to the 9th grams. Well, man, I pressed plus instead of minus. My mistake. All right, let's take a look at C over here. We're multiplying here, so I don't have to worry about moving decimals at all. It's a little bit easier in my opinion. All I have to do is multiply those values, 8.99 multiplied by 3.57, come up with a value of 32.0943 times 10. Okay, so I'm adding negative 4 plus 4. So 4, make that a negative, plus 4. That's 0. So it's times 10 to the 0 power. But this is not in proper scientific notation. I need to move, this is too large, I need to move this one to the left. So this will become 3.20943 times 10 to the, which way did I move it? 1 power. To the 1 power. Right there. Again, still haven't considered significant figures. 3 significant figures. I need to report this to right there. 9 tells me to round up. So the answer that I actually report as my final answer, after all that stuff, is, you see, it's meters times meters, so meters squared. Let's finish up with D. We're dividing here, so let's start by taking care of the... Actually, you know what? Let's do the exponents first. So make a 3, that's a negative, minus the 4. So it's a negative 7. So it's going to be times 10 to a negative 7 grams per milliliter. But what's the coefficient? 2.17 divided by 5.022. 0.43098. I will stop writing right there because it's clear that I only need 3 significant figures, which is right here. 9 tells me to round up. So 0.431 times 10 to the negative 7. But wait a minute, that's not in proper scientific notation. I need to move that one place to the right. So I will have 4.31 times 10 to the negative 8. So I went that way. Sorry, writing behind the calculator, my bad. 4.31 times 10 to the negative 8 grams per milliliter.